Hi. So I saw this on eBay and I thought it looked quite interesting. So I'll just bring the listing up so you can have a look. And what it is a spectrum analyzer clock that you plug your phone into. So we'll just get it out of the box. So that's it there. It looks in brand new condition, but it's faulty. It doesn't work. So it takes a USB-C input there. I'll just zoom down a little bit so you can have a look. And it looks like you've got a little battery backup for the clock. But when you plug it in, apparently it doesn't do anything. So let's get a USB-C lead and plug it in. Right, got a USB lead here. And it doesn't do anything. Let's get my little USB tester here. Just plug that in there. And it's drawn about 1.1 amps. Which seems a bit much, but it's not actually doing anything. Right. So I think I'll bring the microscope in on this one. We'll have a look over the circuit board, see if we can see anything obvious. And then hopefully we'll see if we can repair it. Right, I'll get the microscope set up. So this is the TOMLOV 4K Autofocus Max microscope that I'm using today. So let's have a look over this board, see if we can see anything. So this is where the audio comes in. We've got a little microphone there. I'll just find something to point with. A little microphone. A couple of ICs there, I guess they're op amps or something. This looks to be where the power comes in. It looks like you can use either the side port or the port on the back. And it looks like it shoots off down here into this little power supply by the look of it. I'm not sure what that IC is there, but it looks like the output of this goes into that pin of that IC. I've got a couple of capacitors, and then this looks like a voltage multiplier circuit, which I guess is being used for the high voltage for the vacuum fluorescent display. Right, what's that chip there? It looks like a 74HC595. So I believe that's a shift register. We've got some buttons here for up, down and enter, I guess, which it looks like you can use this header for as well, because it's got up, down, ground, and O I guess is OK. Yeah, so it looks like the output of the high voltage circuit possibly goes up here. What we've got around here then? So these look just like the driver transistors. And again, more 74HC595 chips. That's probably a real-time clock, because the power from the battery goes into that. And I think those are the same chip, possibly. Actually no, it was a microchip one on the floor heating thermostats I just looked at recently. And I guess this is the main microcontroller here, which is an APM32 F10 3CBT6. It looks like it's got an 8 MHz crystal there. And that looks about it. Right, so I think what we'll do is we'll connect some power up to it and we'll see what voltages we're getting. See if we get any voltages on this little power supply here. Alright, I shall go plug it in and get the test meter. Right, so I've got it plugged in. Let's get the test meter on it then. So let's use the USB socket here as a ground. And let's see what we get on this capacitor going into this little power supply here. About 4.8 volts there. So it looks like the output will be here. Let's see what we get on there. About 7 volts, which seems a little bit low. Let's see what we get on these ones. Minus 38. So this is the voltage multiplier here, so let's see what we get on the end of this. Let's see, about minus 39. So unless this is the output of the voltage multiplier at this end. Yeah, that could be the output of it that goes up to here maybe. Let's just try on this diode here, see what we get. Right, we're getting power there. Let's try one of these logic ICs. So if I go on to this pin here, and that one there, I've got 4.8 volts. Just hope it's not a problem with the actual display itself. I couldn't see any cracks or anything in it, but you never know. Let's just see what we get on this one. .8. I'm not sure of the pin out of the processor. Let's see if I can move it up there. Well, that looks like a power rail going to it, so that'll be the 5 volt rail from the USB. So let's just double check what we're getting on here. And let's just see what we'll get on the output going to the chip here. I guess it's probably about 3.3 or so. Yeah. That leads around the wrong way. Let's see what we get on this one. 3.3. Well, I haven't found anything obvious up to now. I don't know if it's worth getting the thermal camera out and having a look with the thermal camera. Let's do that. Right, so this is the Kuwait KTI W02 thermal camera, and if you want one of these, I'll left some links in the video description. So let's have a look, see if we can see anything getting hot there. Well, that's the processor, which doesn't look overly hot. I've got something getting quite hot there though. What's that, about 70 degrees? That looks quite hot. And that looks like that IC there as well. So I guess it's that IC here and that diode there. Right, so I'm going to unplug this for now, and then we'll get this under the microscope again. We'll check out this diode and this IC. Right, so let's check this diode and that then. So I'll put the meter onto diode check. The diode's actually okay. I thought that diode would have been short, but it's obviously getting hot because something else further down the line then. I'm not sure what this IC is here. I'm just going to have a look, see if I can quickly find a data sheet for it. So I couldn't really find much on this IC. There seemed to be a lot of people looking for it, unless it was one with the same number, but it was coming up with something about an automotive IC. But I did manage to find one sheet that mentioned it, and it seems to be a motor driver. So I think what they're doing is they're taking the voltage from this little converter here and then converting it into AC by switching this backwards and forwards and then putting it through the voltage multiplier here. Let's check these diodes here just in case one of those is short. So swap the leads round and we'll do those ones. Well, all those seem okay. Let's just check this one up here. That's okay too. Let's see if we've got any shorted capacitors or anything. I don't appear to have any shorted capacitors or anything either, so we've got another diode up here. Let's just check that one. Yeah, that's okay. Well, I can't see anything obvious up to now. So I wonder if this is actually switching this little power supply and if this chip's oscillating. So I might get the scope out and we'll try scoping on the inductor here to see if we're getting any oscillations, and then we'll try looking at these outputs just to make sure that they're switching. Right, I'll go and set the scope up. Right, so I've got the scope set up and I've got power to the display here. So let's see if we get any oscillations on this inductor here. Yeah, it looks like that's oscillating. Yeah, you can see it there. So, are we getting any inputs to here? Yeah, we're getting a nice square wave to that pin and a nice square wave to that pin. Right, and we're getting outputs then. Looks like we're getting a square wave there. Oh, looks like we're getting a square wave there as well. So it looks like this port's actually working then. So I don't know why that's getting hot. Unless it's just supposed to do that, but let's try on some of these pins on the display to see if we're getting any data. Might have to adjust the scale a bit here. And just adjust the timing. Right, well it looks like we're getting data to the display there. You can see it changing. think these must be sort of like, say, the columns, and these must be the rows or something like that. I'll just turn the trigger down a bit, we should be to see. Yeah, you can see the different pulses there. If I turn the time base down. There we go. You can see all the different pulses there. Yeah, so these are probably the columns, and these will be the data going to the rows. So it looks like the processor's working as well. So I'm just hoping it's not a problem with the actual display, because that'll be a bit of a bummer if it is. I'm not sure what to test now then. I'll do a little bit more research on some vacuum fluorescent displays just to see what the voltages are. But I know there's supposed to be a high voltage, I know there's supposed to be a voltage across the heater filament, which I'm not sure if we've got. And then obviously we've got the voltages to the segments and that and stuff here as well. This looks a bit weird, that. I'm still not sure if there's a problem round about here, but everything seems to measure okay that I've checked up to now, so I don't know with this one at the moment. So I think what I'm going to do, I just want to isolate this power supply from this part here. So I'm going to remove that chip, and I just want to see what voltage we're supposed to be getting there. We'll just see what voltage we're getting there first, because I can't remember. Let's see what voltage we're getting on this output here. So if I go from ground, and just go on to here. So we're getting about 7 volts. So I'm going to remove that chip, and then I just want to see what voltage we're getting on this little power supply. So let's switch it off, and I'm just going to add a bit of flux to this IC, and I'm going to use some low melt solder because I've got some electrolytics yarned. I'm not going to use hot air just in case they go pop. Let's see, low melt solder is great for removing chips and stuff if you've not used it before. As you can see, it stays soft for ages, so like that. And I'll just get a bit of solder wick and we'll just clean up those pads. I'm just going to use a little bit of IPA and a cotton bud just to clean up the flux there. Right, let's power it back up and let's just see what voltage we get there now. I'm just curious. Let's get these scope probes out of the way. So we'll get about 6.9 volts. Well, the current drawn dropped right down, but I've just noticed next to the socket here it says 5 volts 2 amp, so whether or not it draws an amp normally, I'm not too sure. So I'm going to refit this chip because I've just been reading on a forum there about the heaters, which should be from this pin here going to this pin here, and it's normally about 5 volts or so, but when I measured across these 2 pins I didn't actually get anything. But they said another way to check is to see if you get a dull glow in like a really dark room on the filaments. So I'm going to fit this chip, I'll refit it rather, and then see if we get any faint glow on the filaments. Right. here. And I think I'll just put a blob of solder on one of these pins first. I'm just going to add a bit of flux. And just get that IC roughly in the right place. Right, that's about it. Let's do the other side now. Right, I think that'll do. I'll just give it a quick clean up. Right, so I'll plug it in. I'll spin it over. And I'm going to turn the microscope light down just to see if we get any faint glow. I'm going to have to turn the rest of these lights off as well. I can't see any faint glow there. Looks like this microscope's got some built-in lights. So that's not really helping. I don't think we're getting any glow on that. Let's try unplugging it and plugging it back in. No, I can't see any glow on there. Right, so it's been a couple of days since I last looked at this. I've just had some other things that I needed to do. And I think we weren't getting any glow on these heater wires. So let's just plug it in again. Now, what I've realised as well is that this filament is actually AC, and I think I was measuring it on DC, so I wasn't actually getting any voltage there. If we go on to AC volts, we are getting 1.3, but because it's at a high frequency, my meter mightn't be picking the actual voltage up correctly. So I think what we'll have to do is hook it up to the scope, and then we'll be to see what the actual voltage is. So I'll hook the scope up and then we'll have a look. Right, I've got the scope hooked up there, and I'm just using one side of the filament as a ground. And if we go on the other side of the filament, you can see on the scope there, I'm on 2 volts of division there, so that's about maybe about 14 volts there, swing from peak to peak. Looks like that quasi, I think it was a Stirling inverter I looked at, that was a quasi sine wave. It looks like a very similar waveform to what that was producing. So we've got voltage across the heater as well by the look of it. So I'm beginning to suspect the actual display on this, unfortunately. Right, let's have another look at the display then. We'll get this under the microscope. Right, so this is the vacuum display here. And what we can see here, these are the heater wires, which are also the cathode of the tube. And what these do is these emit electrons which head towards this grid, which is this honeycombed structure underneath, and there's one grid per column on this display here. So that means they can select each column separately, and you can also use the grid to control the brightness as well. Now underneath that we've got the anode, which is these pads here, and they have got little dots of phosphor on, and when the electrons hit the phosphor they make it illuminate, and that's how the display actually works. And the reason why they use AC on these wires instead of DCs because the voltage would vary across the wire. So you would have, let's say, more voltage at this side, and then it would be obviously more negative as you went across the wire, so you would get a brighter effect at this display, and it would get dimmer as you went across the display. So they use AC to stop that from happening. So what else have I got here? Now let's remove a bit of this plastic here, and this thing here is what's called a getter, and what it is, it's a little disc that's got something called barium in it, and if the tube has a leak, this tends to turn white because the oxygen that gets sucked into this tube, I forgot to mention this is actually a vacuum tube. Because of this air in here, it'll stop these filaments from giving off as much heat because the air will absorb the heat. And also it's harder for the electrons to move through air, whereas if there's a vacuum, it's easier for them to move. So what this thing does, if air gets into the vacuum tube, or if there's any remaining air after it's been vacuumed, this device here will actually soak up any oxygen or nitrogen molecules that's left in here, and it reacts with it, and they turn white because it turns to barium oxide or barium nitrides, as far as I'm aware. So let's just have a look, see if we can see anything else here. I mean, there's no cracks in the display or anything. Let's just pull this part back. Now I think we might have found the problem. So if we can see here, we can see like a white ring around here, and that should be black. So I think air is getting in, and more this side of the tube than the other side, because if we compare this one, how it's white, and then I might as well just pull this plastic off here now, it'll be easier, and then compare it to this one over here. You can see it's much darker. So I would say air's getting into this vacuum tube over at this side somewhere. Let's just see if we can zoom in on this bit. Right, so I've adjusted the microscope a bit higher up so I can get in with this a bit better. Now if we look here, this is where the heater pins go into the vacuum tube, and this is the side where the getter doesn't actually look too bad, it looks still fairly black. Now if we go across to the other side of the vacuum tube, what have we here? Looks like it might have broke away there, and just a tiny little bit of air might have gotten in through where it's being sealed with this glue. And this is the side where the getter's all white. So I think we've found the problem. Now I don't think you can buy these vacuum tubes separate. I think I've only seen them where you can actually buy the whole module rather than the actual tube itself. So we might not be, well, I don't think we're going to be able to repair this one. Well, I had a bit of a crazy idea. I've got this old fridge compressor, and I thought, I wonder if I can pull a vacuum on the display with this fridge compressor. I don't think it'll have enough vacuum power though, but I thought, well, we'll give it a try. So I'll just plug this display back in, and I've just snapped a little nipple on the end of this display, and the other getter has turned white now, the same as the first one. So right, let's switch this on. Like I say, I don't think this will work, but it's worth a try just to see if we could pull a vacuum. I don't think it'll pull down enough. No, that's about as much vacuum as I'm going to get with this little pump. But I just thought it was worth a try just to see if we could actually get it to light up. But I definitely think that's what the problem's been. So I was busy editing the video and I wasn't quite happy that we hadn't 100% proven what the problem was. I mean, I was 99.9% sure it was the display, but not 100%. I mean, everything else seemed to check out, so it was the only logical conclusion that I came to. So what I thought I'd do is see if I could find another display. And unfortunately I can't get one of these displays, so unfortunately we won't be able to replay this one. But I found this old display on a satellite receiver, I think it was. So I thought, well, we'll couple that up to the grids and some of the segments on the display, and we'll plug it in, so we should get something lighting up if everything's working. But obviously it's not going to show like a spectrum analyzer effect unless I try to wire up everything else, but yeah, we'll not go there. Right, let's plug this in, and I'll just switch the light off a moment so we can get a better view of this. And there we go. I'll just zoom down a bit more. There we can see some display lit up there, some segments on 4 different grids here. And if I press this center button, it makes them all light up there. And then it must be going through menus or something. You can turn the brightness down by holding that button there. You can see it's gone dimmer there. And if I hold the other button, it makes them go brighter. Now this display has got some of the segments burnt on it already, so it's not really the best display in any way, this one. And you might just be to make out the heater wires there, they're just glowing slightly orange. I don't know how well that's showing up on the camera there. But at least we've now proven 100% what the problem is. Right, I'll just switch the light back on. So unfortunately a no fix on this one, but at least we definitely know the problem. So right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.